So here we go. This is another one from our study guide. It's actually 1992, FRQ number 4 from the AB test. So they give me this equation right here, and I, part A, want to find dy dx, and they say in terms of y. So that means that I want to have dy dx equals stuff with y's in it and no x's. So that's what they mean in terms of y. So the first thing I'm going to do is derive this thing with respect to x. So I'm going to dx this. The first thing gives me y prime. Some of you may find it easier to see chain rule if the second one I rewrite it like that. So I get y prime, that comes from this guy, plus chain rule on the cosine of y gives me y prime times, and I got to do the derivative of cosine, so that's minus sine of y. And then on the right side, I get derivative of x is 1, and the derivative of 0 is nothing. So now I need to solve for my y prime. If I write y prime times equals 1, I like to do this to try to factor this piece, this piece right here. So y prime times what would give me this? Well, y prime times 1 would give me that right here. And then y prime times what would give me this term? Well, I've already got it kind of written out for me, the minus sine y. So I get minus sine y. And I'll just point out when I say y prime, I mean dy dx. So if I divide by the parentheses, I get y prime, which is dy dx, is equal to 1 over 1 minus sine of y. And that's my answer for part A. So I'll do part B in the same video here. For part B, they want the equation of a vertical tangent somewhere in this, of each vertical tangent. So I've got this guy right here. Actually, I'm going to do that in green. I'm going to come back to this, and I'm going to use this right here. So I get a vertical tangent when the slope is undefined, you know? Like, I want to have a slope that goes straight up and down like this. If you think about dy dx, well, I don't have a way to describe that slope in terms of a number, so it's when the bottom of the fraction is 0. You could also think about it as if I were to draw a triangle. You know, normally when I have a slope, I do delta y, delta x, right? And I divide the two, right? So notice here the delta x is equal to nothing when it's straight up and down, vertical. And then if you look at my equation here, the dx is that bottom piece, right? So I can think of the bottom piece as being 0. So when I'm looking for this vertical tangent, I set 0 equal to 1 minus sine y, which gives me sine y is equal to 1. I think about the unit circle, only going from 0 to 2 pi. Well, sine is the y-coordinate, so you should see there that that's the only place on the unit circle where the y-coordinate is 1. So that means that the solution to this is y equals pi over 2. So, I have my y-coordinate, but that doesn't do me any good for the equation of the vertical tangent. I need to write that in a form of x equals something, because that's how I define, like, if I've got 1, 2, 3, 4, and I've got a line that's vertical at 4, I would call that x equals 4. So same thing here, I need to get this thing's equation, and I know the y-coordinate, but I don't know the x-coordinate yet. So that's what takes me back to this right here. This relates y and x. And if I plug in my pi over 2 for y here and here, then I can solve for x. So, just to reiterate, I rewrote it over here to give myself some more space, but I'm going to take this original equation right here. I'm going to plug in y equals pi over 2 and get the x value, and that's going to be the equation of my line. So, as I plug it in, I get pi over 2 plus cosine of pi over 2 equals x plus 1. Now, I just used the unit circle right here to figure out that y value, right? And I know I'm looking for the cosine of pi over 2, which is this spot right here. I also know cosine is x, so I know that this term right here is equal to 0. So I get just pi over 2 equals x plus 1, and that gives me x equals pi over 2 minus 1. And now this seems kind of anticlimactic, but that's actually my final answer, because as I said before, I needed to find a form x equals to, just like my example right here with x equal to 4. So I've gotten to that, and I know that this is the equation of the vertical tangent to that original graph.